The natural resources of northern Michigan are changing. Lakes and streams, wetlands and uplands, and forests of all kinds are showing the impacts of development, the invasion of non-native plants and animals, and the changing climate. The natural beauty, clean waters, and abundant wildlife that we hold so dear are at risk. But what are those risks, and just what is changing? How are resource experts and community organizations responding? And what can we do to protect our incredible natural resources? Welcome to Nature Change. In this program, we visit Michigan DNR's Charlevoix Fisheries Research Station to get an update on the conditions in Lake Michigan. We visit with Jory Jonas, a longtime fisheries research biologist with the DNR, and her newest colleague, fish biologist Ben Tershak. We're delighted to have Peter Payette, Executive Director for Interlochen Public Radio, leading this discussion.
Hello Nature Change viewers, I'm Peter Payette, I'm the Executive Director of Interlochen Public Radio, and I'm here in Charlevoix at the Charlevoix Fisheries Research Station, which is owned and operated by Michigan's Department of Natural Resources, and this is where fisheries biologists operate from to go out onto Lake Michigan and to try and figure out what is happening with the ecosystem, which is in a constant state of change. And we have a couple of those fisheries biologists here with us today. I'm with Jory Jonas and Ben Tershak. Jory, you've been here 25 years at this 25-ish, and Ben, you're just fresh off the boat, right?
6 months,
6
that's
months.
right.
Well, welcome. Welcome.
Thanks.
And so welcome to our viewers. Thanks for taking time to talk with us. It's always a great pleasure of mine to talk about and hear about what's happening out there on Lake Michigan. Why don't we start by talking about alewives? As some viewers may know and be aware, the alewife are a really important species in the environmental economy of Michigan, shall we say. It's a non-native fish. It came in, 75 years ago, but it's important to us now. Your efforts here focus a lot on what's happening with alewives. Mm-hmm. Explain why we care so much about this fish.
So the alewife, first came into the upper Great Lakes systems through the St. Lawrence Seaway when connectivity was made between the lower and upper lakes to facilitate shipping traffic. As the access was available to these upper lakes, the populations of alewife rapidly exploded. So there were a large number of them, which can happen often when you have an invasive species. They tend to come in and really explode, like the zebra mussel has done, like around Goby has done, and then they'll level off to a more reasonable place. With the alewife, however, their abundance stayed pretty high. They didn't have any predators that were really focusing in on them, or enough predators focusing in on them to keep their populations in check with the nutrients and the productivity that were available in the Lake Michigan system. So a former Michigan DNR employee, Howard Tanner, saw an opportunity to bring in fish, the Chinook salmon, who really prefer alewife to eat as prey, to the point where they almost don't eat anything else. We call them specialists. So Chinook salmon, specializing in eating alewife, created an amazing match that really stimulated, and it was a successful combination in terms of getting these nuisance levels of alewife under control. Municipalities didn't have to pay for big suction vacuums to pull up dead alewives off the beach. People weren't afraid to go to the beach because of the smell any longer. The Chinook helped rein that type of effect in. However, the underlying construct here is that the alewife reconstructed our ecosystem and the nutrient dynamics within that, and continue to do so, as do other invaders to this day. And what we worry about are these broad fluctuations. That's tough to work with. Our public do not like when we have broad fluctuations. It's hard to make a living off of an area that's always changing.
Yeah, and as Jory pointed out, these things are the critical linchpin for the salmon fishery in Lake Michigan. Mm-hmm. So they provide that.
Linchpin's a great word.
Right, yeah. They provide that critical prey species for those salmon. And so it's great when we have, lots of alewives, but their numbers have sort of been declining, ever since the introduction of salmon. And while they've fluctuated on the way down, they've pretty much, continued down. In the last few years, we've had really record lows of these things with, again, fluctuations in there. In 2010, we had a really strong year class of alewives that came in. In 2012, we had an above average year class. 13 and 14 were not good. 2015 was a little blip, and then 2016 was not good. And 2017, I don't have the data fully worked up here, so I don't know exactly what those numbers are going to be just yet.
But you were out there
Right.
on the boat looking at the screen.
Yes. Yep.
You didn't. Nothing happened that would suggest it was a banner year.
Yeah, so because this was my first year doing that survey, I don't really have a frame of reference to compare to, but my sense was that the numbers were still low.
Yeah.
We didn't see any population explosion. I wish I could say that, but I didn't see anything that would suggest that there was tremendous numbers of alewives out there.
Right. Are we getting to the point where no one should expect it to rebound? I mean, at a certain point, the population of fish can't come back, right?
Correct, and I mean, that's the million-dollar question, right? And something biologists debate endlessly right now. Looking at the experience in Lake Huron, there are groups of people who say that Lake Michigan, cannot avoid landing in the same place that Lake Huron did, which was almost a complete collapse of the alewife populations, and they have not since recovered. And then there's another group that says, with the productivity in southern Lake Michigan and Green Bay and some of our drowned river mouth ports, it's possible that we could buffer and hold through these low recruitment years and still recover. But really, we don't know the answer to that. And certainly in terms of sport fisheries and economics to the region, the Chinook salmon alewife complex are a big deal. They're big.
It's the biggest
part
deal,
of the
right?
economy, yes. And so it's very important to people, and we're doing everything we can to work with the public and managers and other jurisdictions to try to create a more stable balance in that system. And it may be, other people have used the term the new norm. We may have to adjust our expectations down from what it had been. But as Ben mentioned, there's also kind of been have we been putting too many predators out there all along? Was that an unrealistic thing, even when they were both high? They talk about top-down versus bottom-up influences. So Chinook salmon are on top, right?
Yeah.
And are they the lawnmowers cropping off the alewife? Or is there something coming up from the bottom, quagga mussels and nutrient dynamics, which are influencing them? Or is that something in between?
What do those arguments matter in the long run? Because, really the only thing that the state can do is put fewer predator fish into the lake.
Deal with the top down.
That's the only place you can make any change, right?
Yeah, you're right. There's not that many levers we can pull, right? There's really only a couple things. Jory had mentioned that, like quagga mussels and trachinid mussels in Lake Michigan, how they've really reduced the amount of phytoplankton in the lake, which in turn, affects the trophic levels above them. So each step in the food chain above them, if there's less at the bottom, it can support less above. And so there's some debate, I think, about whether or not increasing, the amount of nutrients going in the lake might kind of curb that effect. But so that's a lever that could potentially be pulled.
Fertilize the lakes.
Right, but the problem. So there's a huge problem with that, though, and that's that these mussels have fundamentally changed the way the lake works. And so I think that's the misconception, right? Is that you could put these nutrients in the lake and fertilize it, and that that's a potential management action. But in reality, it's not a good route probably, because mussels, phosphorus can come into a system. From rivers. That's how it gets in, and it flows out through outflows, and it also settles to the bottom. Those are kind of the three pathways that this nutrient goes. And so the amount of phosphorus you have in the lake is determined by inflow, outflow, and settling. And mussels have come into the lake and they fundamentally changed that. We're now, they're out there, they're covering much of the lake bottom. I mean, in some places their densities are 100,000 per square meter, like really high densities. Yeah, so you're talking an area this size with 100,000 mussels, each, you know, I think capable of filtering something like a liter of water a day.
Yeah.
So they're really, that filtering capability is huge.
And the other thing they do is they create a pellet called a pseudofeces. And
Yeah.
what it does is it really locks up those nutrients and
Right.
keeps them there.
Right.
And so that's another thing we talk about is the nutrients are getting sequestered in this zone. They're not, putting more out there doesn't mean there'll be more available, just means there'll probably be more locked up on the bottom, creating a potential risk scenario. If there were resuspension, then you're going to have another wide flux as everything goes green and crazy.
Right. I like to use this like kind of comparison where we used to have alewives washing up on beaches, and Howard Tanner kind of saw this as, he has a quote saying that, you know, this was wasted energy, you know, in the lake, and that you could put Chinook salmon in there and create this fishery and kind of use some of that energy that was being wasted and just washing up on beaches. We don't really see alewife washing up on beaches anymore. We see algae that grows on the bottom washing up on beaches. So it's sort of this new wasted energy in the lake. And you could, you know, maybe you put more nutrients in the lake. I don't think you're going to see alewives washing up on beaches. You're going to see more algae washing up on beaches. And so
Right.
and it's something that we can't take advantage of in the same way that we could take advantage of alewives.
So do the inability that alewife have to reproduce to a great extent right now, are we seeing that in other fish species? Are most types of fish having trouble reproducing in the wild, or is
It certainly varies from year to year, and I guess like I said, I'm just getting into this right now. I'm not an expert on which fish are recruiting the best on any given year, but there's been declines kind of across the board in those sort of open water forage fish species. So things like rainbow smelt and bloater are a native Coragonid. Their bloater numbers have declined in a really big way, but recently we've seen kind of an uptick, it seems like, in their numbers.
In southern Lake Michigan.
In southern Lake Michigan.
Whereas smelt have been showing a little bit of an uptake up north. I like to think of it this way, and I think we're still in the middle of another system reboot, and we don't really know what that's going to look like when it settles out. So you ask about, are all things having these same kinds of problems? I think the answer is no, there's not concurrence, although there is that general decline in most forage species that you can watch over time that seems to correspond with zebra mussel, the Quagga mussel expansion timeline. Would you agree with that?
Yeah.
And
you're saying generally as zebra and quagga mussels go up, all the native fish species and non-native fish species
in a pretty marked way
go down.
from high levels to low. And what we're talking about now are these fluxes within this lower level.
Right.
The other species that are interesting, though, Cisco and lake trout populations, two native species, are doing quite well right now and reproducing naturally for the first time in generations. You know that. So something in this new reboot appears to be working for those two species, whereas now lake whitefish are showing recruitment problems in recent years. And that's a bit of a mystery because they're virtually brothers and sisters with the Cisco in their life history and spawning periods. And why one of them is thriving right now and the other is not is a huge question that doesn't make sense.
And Cisco, we should say, is sometimes
Lake
referred
herring.
to as lake herring and looks a heck of a lot like a whitefish,
Yes.
as you were saying.
And most people couldn't tell them apart, probably.
Right. And when you say it's thriving, what do you mean?
I mean that we went in 2010, the harvest of Cisco in Grand Traverse Bay was probably 20, 50, not much. And as of last year, they took 14,000 fish out of Grand Traverse Bay.
And the harvest, this is sport anglers
Sport anglers.
reporting how many fish they're...
Yes.
Okay, that's quite an increase.
We call that an exponential increase. It's just about doubling every year.
I mean, if you went back 10 years, it was that the Cisco population, it was believed that a few fish were just spawning in one
Barely holding
particular
on.
place.
Right.
And now it's
Exploding.
spread all across the basin.
And we see a similar pattern at the intake at Ludington Pump Storage Plants. We can mark this kind of an increase throughout the eastern and northern areas of Lake Michigan. So
For Cisco,
Charlevoix,
it's
yes.
happening all over.
Yeah, well,
With-
around these areas. And
Certainly.
we believe we're seeing a radiation out, so that as that expansion occurs, you see the distribution start to expand as well.
Right, and this is happening with no human assistance, because you
Yeah,
mentioned
right.
the lake trout. We've been putting
Right.
millions and millions and
Yeah, no,
millions of
this is
lake
just
trout in.
kind of
This is
happening,
just
surprise,
happening.
yeah.
Right.
And really, over the last 5-6 years, we're scrambling to keep up with it and
Mm-hmm.
understand it.
So, but then maybe, Ben, the loss of alewives and the expansion of goby isn't a bad thing. Maybe that could be good for a lot of these other fish.
Right, it is. It seems like it is benefiting some species, and some species more than others. So if the name of the game is to have more Chinook salmon in the lake, having a bunch of gobies probably isn't going to help a whole lot. We don't have a lot of evidence around goby and Chinook salmon diets, but for other species, it might be really good. Lake trout are able to take advantage of them. Brown trout are able to take advantage of the round gobies that are there. And these species certainly still eat alewives, and that's an important part of their diet, both in terms of gut content, and we can also use like a tracer called stable isotopes, which lets us kind of look at the more long-term diet of a fish. And both these kind of lines of evidence would suggest that round goby are more important in the diets of lake trout and brown trout, and maybe even to a certain extent steelhead, than they are for coho or Chinook salmon. So if your end game is to have lots of Chinook salmon in the lake and you don't care so much about everything else, round goby may not be the answer to your problems, but it's certainly better than not having any forage fish out there for these species.
What if your end game was a diverse fishery? Because I've heard smallmouth bass added to the list related to doing well, eating round goby. I've heard of burbot, which people may not know what a burbot is. There's a great one right here. I've heard they do well with goby. I've heard whitefish eat goby.
Just about everyone
Just
eats
about
a goby.
everything except the Chinook salmon.
The specialist Chinook
Right.
want their alewife.
Yeah, so if you're looking for a diverse fishery, it's nice to have diverse forage, and so a forage base that includes alewife and round goby and all the other bloater and rainbow smelt and all those things would be beneficial. And I think it's good to have that diverse those diverse predators in the lake and those diverse fisheries, because then when something happens to alewife, for instance, or any other species, there's
more resilience.
Yeah, there's more resilience built into the system. Yeah.
So, what's the problem with round goby? Should we be distressed when we see these prey fish reports saying more and more round goby?
I've been known to make the controversial statement that the best thing that's happened for native species restoration in Lake Michigan is the round goby. This is all a part of that architecting the system and how new things come in and good and bad happen, right? And so the zebra and quagga mussels were a big hit. And I almost want to say the fact that the round goby followed them is probably helping to equalize a little bit of that hit. And they're helping to convert some of that nearshore zebra mussel, quagga mussel biomass into more productive, they're themselves forage, they're adding to productivity in nearshore zones in meaningful ways. So again, it's hard to paint everything as either evil or good, right? They are all players in the system.
And I think that depends on your lens a little bit too. So if you're looking through a lens of predator fish, like trout and whitefish and Cisco and brown trout, then yeah, round goby were great. If you're looking at a native species like mottled sculpin, some kind of small species, there's a lot of competitive interactions there that may not be good.
And what they've done though is they've changed their distribution, not their abundance overall. So.
They move different places.
Right, they don't coexist very well. So I no longer find sculpin in the nearshore zone of Lake Michigan, but their levels offshore are still pretty high, and in fact, they've moved further offshore, I think, than
Well, yeah,
had been previously documented.
right, slimy and deep water sculpin,
Yeah.
but mottled sculpin in the really shallow waters seem to be,
They're gone.
yeah.
Yeah.
So if you were at a social event, a little cocktail party in the evening, and someone asked, how's Lake Michigan doing? How would you answer that?
I would say that it's in a constant state of change, and it depends on who you are. You know, if you're a lake trout, you might be doing all right. If you're an alewife, maybe not so much. So it's certainly ever changing, and not necessarily for the better or worse. It's just different.
And you think that'll be constant? There will be ups and downs going into the future.
That's been my experience so far.
I tend to run in the side of optimism, so I would say I'm pretty excited about the lake herring populations and some of the natural reproduction we're seeing with lake trout, some of the expansions in bloater populations, and you know, there's a lot of positive signals out there. The fact that Chinook salmon condition levels look good last year, we had fewer empty stomachs, despite having some of the lowest forage available. I think that perhaps we've brought that ratio of predators and prey into a better place, where we're not driving it down quite as hard as we were. So there's my optimism. However, that being said, I mentioned earlier in this interview that I feel like we're in the middle of another major shift, and that makes me nervous because I don't know where that shift is going to land.
What gives you that sense?
The Quagga mussel biomass increases that hadn't even leveled off until have we even leveled off now? Are we thinking?
It depends on where you're looking.
Yeah.
And it seems like in near shore areas out to, I don't know, maybe 50, 60 meters of water, that their numbers are kind of leveling off, but in the very deep waters, they might still be increasing.
And gobies are redistributing themselves in accordance. You know, I think you're seeing them start to move offshore a little bit. I still think there's just a lot of balls in play right now, and how that's ultimately going to end is to me a big question that makes me anxious.
Ben's suggesting it doesn't end. It just keeps sort of tumbling forward
Well,
pell-mell.
and then we get into my lifetime as a scientist versus his, and in his lifetime as a scientist, there have been quite a few big bangs that have come in here. You know, it's been zebra mussel, quagga mussel, hemimysis, round goby, you know, it's just boom, 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 you know, who's next? I don't know.
I once commented to one of your colleagues here, I said, that must be frustrating because you start to focus in on something and then it changes. And he said, no, I call that job security.
I don't need that kind of job security. We could stop that cycle anytime now.
Thank you both.
Thank you.
Thanks.